The next lesson on measurement has to do with tolerance. Now, the idea of tolerance is kind of what are we willing to accept in terms of a measurement. Okay, so I'll give you a couple of examples. If you were ordering, say, some dirt for your yard, and you said, I want a yard of dirt, okay? A yard is a unit of measurement. You would be willing to accept if it was a little bit too much or a little bit too little. It wouldn't be that important. Okay. On the other hand, if let's say you were getting a pair of pants, and you're like my waist size is 36. Would it be okay to get a 38? Would it be okay to get a 34? All right. What would I be able to tolerate? I could probably tolerate a little bit looser. I could probably tolerate a little bit tighter, but not too much. So what's my tolerance level there? What am I willing to accept? Okay. If you think of your kitchen cabinets, you walk into your kitchen and you know that you can open each door individually and they don't bang into each other. The tolerance for a set of kitchen doors would probably be very small, because if you were way out with your measurements, they would be banging into each other all the time. You wouldn't be able to open one door without getting the other one out of the way. Okay? Even more important is something like if you think about medicine. All right? You just can't take a wrong amount, because too much of something would be unhealthy, and too little of something would actually not work. Okay, so the level of tolerance is more particular in some cases and less particular in others. So let's take a look at the lesson. You should be as accurate as possible when measuring, and make your measurements precise enough for the task you are doing. That is, when you are manufacturing goods, a range of measurements is often acceptable. This range of acceptable dimensions is called tolerance. Okay, the tolerance acknowledges that things need only be acceptable for the job they were intended to do. The concept of tolerance is important because when you install and assemble parts, they must fit together, they must work properly, and look right in many cases. Okay, so for example, here's an example from the kitchen. Two parts of a hinge, they have to fit together very precisely for the screw to go between them, and they also have to be able to slide against each other but not allow the door to tilt. Okay, a kitchen cabinet installation must leave room for the kitchen door to open without obstruction. Okay, crushed ore. So, okay, here's a question for you guys. Have you ever heard of what quarter down? This. Quarter down. It's a kind of rock that is used for example, if you're putting up a fence and you're trying to keep a fence post tight, you put, these are really, really tiny little rocks. Okay, each rock is about a 1/4 inch across. That's why it's called a quarter down. Okay, so how do you get rock to be small pieces like that? Well, you have a crusher which kind of tumbles the rocks until they break apart, and then you have a screen, and in this case it must allow pieces smaller than a particular size to pass through. So the more you tumble them, the more you bang these rocks together, the smaller the pieces will become. Okay, small variations occur in the manufacturing process. If a range of measurements is acceptable, then a higher number of items can be used. When applying tolerances, you must always ask, what is the fundamental importance of this dimension? Okay, again, the more tolerance you're allowing, in other words, the bigger the range that you're allowing, the more likely that whatever you're making will be able to fit in that range. If you're being very, very precise, it's got to be very low tolerance. For example, if you've ever used a nut and a bolt, so you have a bolt like this that has its little grooves on it, okay, and then you have a nut that will screw onto there. The precision on this is very, very fine, and you can't be out any bit in the measure, otherwise it won't fit on there. So in this case, the tolerance would be very, very small. Okay? The Nominal is the target value for the measured quantity. It is usually halfway between the maximum and minimum values, but it may also be a maximum or minimum value. The nominal value indicates the value to be, aimed for, but an amount of difference above and below the value is acceptable. Okay, so this is kind of what we did with uncertainty before. Okay, so let's take a look at an example. So one more definition here. Tolerance is the difference between the maximum acceptable dimension and the minimum acceptable dimension. Okay, it can be expressed in several ways. We could have the maximum and the min value. We could do it as a nominal value. This is kind of what we just did with uncertainty. Okay, there's bilateral tolerance. So here it gives a measurement and then it says what you're allowed to be up and what you're allowed to be down. Notice they're different. And then unilateral means that the minimum has a plus tolerance. This basically means that there is very little tolerance. You're not allowed to have anything different. Okay. So put a quick definition here. For bilateral tolerance notation, that's this one, the tolerance levels may be different. The upper tolerance level is written above and the lower tolerance level is written below. The nominal value is not the mean in this notation. It's not the average. Okay? I don't think we're going to spend a lot of time with that one, you guys, so don't worry too much about that. The unilateral tolerance, okay, so that's this one. It looks like bilateral notation, but one of the dimensions is 0 and the other is stated with a plus or minus sign. The nominal value is equal to the minimum or maximum in this notation. Okay, doesn't really make sense when we haven't done an example. So let's look at some examples. Okay, for each example, state the lower limit, the upper limit, the nominal value, and the tolerance. Okay, so this you can see is that very first type, the maximum value and the minimum. So the lower limit, okay, is 60 centimeters. The upper limit is 61 centimeters. So whatever this item is, that's the range that is tolerable. Okay. What is the nominal value? Okay, the nominal value is in the middle of that. Okay, so how would you find that? You could go 60 plus 61 divided by 2, it's the average. Or maybe you can just see that it's right in the middle, and it's 60.5. Okay, and what is the tolerance? Well, we're tolerating a difference of 1 centimeter. Okay, let's try a few more like that. Get used to kind of reading these different sort of ways of writing this. So we got a lower limit, an upper limit, the nominal value, and the tolerance. What is the lower limit? What's the smallest this could be? Well, this would be 92 minus a half. Okay, so you would have 91.5. The upper limit would be 92 plus a half. So this would be 92.5. The nominal value, what's the value in the middle there? That's 92. Okay, it actually happens to be that value. And the tolerance is 1. Okay, the space between the upper and the lower limit. All right. You can pause the video here now and try some of these, see if these are making sense to you. So the lower limit would be I'll write it out, 6.384, take away 0.03. Okay, that's going to be 6.381. The upper limit would be 6.384 plus 0.03. That's going to be 6.387. Okay, the nominal value, 6.384, And the tolerance, what's the space between the upper and the lower limit? Okay, well, you could go ahead and find this by going 6.387 take away 6.381. Or you could say, look, if I have added and subtracted the same amount, why don't I just put those two together? If I add those up, I know how much I've gone up and how much I've gone down. Okay, next one. Okay, let's try lower limit, upper limit, nominal value, and the tolerance. Okay, the lower limit is, I'm going to subtract. You can see these are different. This is that bilateral. Okay, so this is 9.95. The upper limit, I don't add the same thing. I get 10.1. Okay, what is the nominal value? Remember, this is not the average, it's this middle value. And what is the tolerance? Well, if you want to add those two up, you get 0.15. Okay. So let's do this. The lower limit, I'm going to subtract nothing. So it's 0.0140. This time it has a unit, so I can put the unit in. The upper limit would be 0.0142. The nominal value is 0.0140, and the tolerance is 0.002. Okay, almost done. Let's do the lower limit, upper limit, nominal value, tolerance. So lower limit, we're going to go 8.4. Okay, so that's 8.7 take away 0.3. The upper limit does not change because it's a 0 to add. So the nominal value is 8.7, and the tolerance between those two ranges is 0.3. Okay. I'd like you to pause the video and see if you can try a few of these, see if it makes sense to you, and then we'll do them together. Okay, so we want the lower limit, we want the upper limit, and we want the tolerance. Okay, the lower limit is 8.231 take away 0.02. So this is going to be 8.229 L, I assume liters maybe. Upper limit will be 8.231 plus 0.002. And so this is 8.233. And the tolerance, if you add those two, is 0.004. And again, it's liters. Okay. So let's try these. The lower limit's going to be 5. The upper limit's going to be 5.7. I guess you should put 5.0. The nominal value, 5.3. Tolerance will be 0.7. Okay. Here, the lower limit, there's a 0 there, so it's just 3.65. The upper limit will be 3.72. The nominal value, 3.65, and the tolerance, 0.07. Okay, can I get you to try assignment 4, and then we will continue with this lesson. Okay?